All right, let's set the scene. You're in the final round for a huge role, Senior Agentic AI Architect. This isn't about memorizing facts. This interview is designed to see if you really have what it takes. You know, the deep, practical know-how to build the kind of AI systems that are changing everything.
Okay, so you're sitting across from a senior architect. This person isn't looking for buzzwords or what you read in a blog post last week. They want to see how you think, how you architect solutions. So let's dive right in. Here comes the first question.
So, they start with what seems like a basic question, but don't be fooled. This is a classic interview move. They're testing your fundamentals, digging into whether you truly get the difference in the core instructions that shape an agent's entire reality.
Okay, so how do you nail this answer? You start by saying, look, they're both inputs, but they live on completely different planes. Think of the system prompt as the agent's DNA, or its constitution. It's the deep-seated set of rules, its persona, what it can and can't do, its whole vibe. It's the stuff that's always there in the background. The user prompt, on the other hand, that's just the right now conversation. It's the specific question you're asking in the moment. And this is the killer point you need to make. The system prompt has way more influence. It's like the guardrails on a highway. The user prompt is the car, driving turn by turn, but the system prompt keeps it from flying off the road. So yeah, a user can try to trick it or ask it to be something it's not, but a well-designed system prompt will always pull it back, making sure it stays consistent and safe. Okay, you've passed the first test. The architect nods, maybe a little smile. Now they're going to turn up the heat. This next one goes right to the core of what makes an agent, well, agentic. It's all about dealing with messiness and conflict.
So the first thing you do is frame the problem. You say, this isn't just about giving the agent a checklist. No. This is about building a system that can actually make a judgment call. It's about engineering a way for the agent to look at two competing goals, weigh the pros and cons, and make a smart decision on which one matters more right now.
And here's how you show you're an architect. You lay out a clear, structured approach. Step 1, you build a goal hierarchy. You literally tell the system, goal A is more important than goal B, using weights or hard rules. Step 2, you give it a brain, a place to think. This is where you bring in concepts like a reflection loop or scratchpad, basically a mental workspace for the agent to reason through its options. And finally, step 3, the agent acts on whatever it decided was the top priority. Laying it out like this shows you're not just guessing, you're engineering. All right, we're shifting gears. The architect is moving from theory to reality, to production. This question is huge because let's be real. If you can't test it, you can't trust it. And if you can't trust it, you can't ship it. So how do you prove your agent actually does what you claim it does?
The magic word here is evals. You need to say that word. And the best way to explain it is to say evals are for AI what unit tests are for regular software. It's that simple. They're the structured, repeatable tests you run to make sure the agent is performing correctly, to see if a new change broke something, and to hunt down all those weird edge cases.
And then you break it down into the two main ways we do this today. On one hand, you've got the classic method, ground truth datasets. That's where you have a big pile of questions and the perfect answers already written down. You just compare what your agent says to the correct answer. On the other hand, you have a newer, frankly more interesting approach, using another, even more powerful AI to act as a judge and grade your agent's work. Now, this is where you really shine. You explain the trade-offs. You say, ground truth is amazing for accuracy. It's objective, it's the gold standard. But man, is it expensive and slow to build those datasets. Then you pivot. LLM as a judge is super scalable and fast, and it can even grade fuzzy things like the quality of the agent's reasoning. But you're trusting another AI, which might have its own quirks and biases. Showing you understand this trade-off is what makes you sound like a senior architect, not just a junior dev. Okay, now the interviewer leans forward. This next question is the one. This is the one that really separates the pros from the amateurs. It's all about security. It's about what happens when your shiny new agent gets access to the company's crown jewels. Your first move is to show you know the enemy. You don't just say hacking, that's weak. You name the specific threats. You talk about prompt injection. That's where a clever user tricks the AI into spitting out secret data. You talk about privilege escalation, where they con the agent into breaking its own rules and doing things it's not supposed to. So after you've laid out the dangers, you pivot to the solution, the fence in depth. You explain it's not about one single trick, it's about layers of security. First, the principle of least privilege. The agent only gets the keys to the rooms it absolutely needs to be in, nothing more. Then you add a layer of rigorous input validation, basically checking everything that comes in for anything suspicious. Then, you run the whole thing in a sandboxed environment. So if something does go wrong, the damage is contained. And finally, you're watching it like a hawk with constant monitoring and rate limiting.
At this point, the architect is impressed. You've covered all the big bases. They have one last technical deep dive for you, and it's a super practical one: observability. The question is simple. Your agent is gonna break. It's just a matter of when. So when it does, how on earth do you figure out what went wrong inside that black box?
First, you start with the big picture. You talk about tracing. A trace is literally the full story of one single run of your agent. From the moment the user hits enter to the final response, it records everything, every thought, every action, every time it used a tool. It's the whole narrative.
And if the trace is the whole book, a span is a single chapter, or maybe even just a sentence. It's one single, self-contained step in the process. Okay, now I'm calling the weather API. That's a span. Now I'm thinking about the answer. That's another span.
And this is how it all connects. You see how these individual spans, the query, the tool call, the final generation, they all link up to form the complete trace. It's like a timeline of the agent's mind. And for a developer trying to debug a problem, this is absolute gold. You can see exactly where things went off the rails.
And that's the bottom line. Without observability like this, you are completely flying blind. It's impossible. Tracing with spans lets you find the exact point of failure, identify why something is slow, and finally understand the why behind a weird answer. It's what takes the AI from a mysterious black box and turns it into a transparent glass box you can actually understand and fix.
Okay. The architect leans back in their chair. They're impressed. You've nailed every technical question, but they're not done. The last part of the interview isn't about what you know now. It's about what you see coming. A great answer starts by tipping your hat to the transformer, the architecture that made all this possible, but then immediately pivots to its biggest weaknesses. You have to show you're thinking about the next frontier.
And that brings us to the final question, the big one. There is no single correct answer here. This is purely a test of your vision, of your perspective. They want to know what you think is the single biggest mountain we still have to climb to make Agentic AI truly reliable. Is it memory? Is it cost? Is it something nobody's even talking about yet? How you answer this, well, that shows whether you're just a builder or if you're a true architect who can see the future.